Okay, so the international radiation symbol here, we got to calculate the black area of the signal. So what I'm going to do is I'm going to start in the middle. I'm going to draw a circle going around the big circle here. Okay. Now each section, you can also segment each section. I'm going to use the green arrows here. Each thing, it's like 6 equal parts, isn't it? So technically they're all 60 degrees. So the parts I need to do are all in sectors of 60 degrees, okay? So if you want to put marks on the board, if you find this difficult and you want to put marks on the board straight away, start with the small circle in the middle, pick up in the 10th mark. Just pick up something, okay? So this one here is going to be pi r squared. What is the radius of the small one again? What is it? R. So I've already picked up pi r squared is part of the question. Okay. What I'm going to do next is I'm going to go for the full thing. I'm going to shade it in blue. So the full thing here. Okay. So what I'm going to do is going to be theta over 360 times pi r squared, which is going to be 60 over 360, which is a sixth. Going to be multiplied by pi. Now, what's the radius of the big circle? 5r. Now, 1/6 of 25 pi r squared, so it's going to be 25 pi r squared all over 6. Okay, happy enough with that? That's the area of one blue region, so I'm just going to sort of colour it in up here. That's your blue region here, and that blue region is 25 pi r squared over 6. Okay, so just put that up there. Next thing, I'm going to now create a red region. The red region is going to be in here, and we're going to take this red region away from the blue region to get the black part on the outside. Okay, so once again it's going to be 60 over 360. It's going to be pi, and it's going to be multiplied by, this time it's 1.5 times the radius squared. If somebody could put in 1.5 squared and then divided by 6, that'd be great. 2.25 over 6. Yeah. Oh yeah, but what would that be in fraction mode? 2.25 over 6, anybody? 1.5 squared divided by 6. 3 over 8. 3 over 8? Yeah. Yeah? 3 over 8 pi r squared. Okay. Now, what we're going to do next, guys, is that the area of the black area, this area here, call it area A, area B, area C, they're all the same area. Okay. What we're going to do is we're going to find out what they are. So we're going to get 25 pi r squared over 6, and we're going to take away 3 over 8. So will somebody get 25 over 6 and take away 3 over 8 for me? And what you get? 91 over 24 pi r squared. Now, there's 3 of these, and when you multiply that by 3, you got to add it onto your central circle, area D, which is going to be pi r squared. And what's the grand answer? Now, once again, ignore the pi r squared. Just concentrate on doing this in your calculator. 91 over 24 multiplied by 3 plus 1. Because 99 over 8 pi r squared. Is that right? Yeah. There's a really easy way for that. Okay, so what happens here, guys, is this. What I'm going to do is calculate the radius of the arc with center at point 0. So what I'm going to do is I'm going to construct a triangle here. This is going to be what way did I do this again? Okay, so the radius of arc with center point. So we need to find out what r is. So r is here, r is here. Ah, yes. It's the same trick we did last time. So let me show you what to do here, okay? So what I'm going to do is I'm going to construct a general circle, something similar. Now, unfortunately, the one in the book sort of out of proportion. It's like it wasn't scanned in properly. It isn't actually a proper circle. So we're just gonna imagine that it's like this. And see this green line here? It's a chord. So the green line's a chord, and I'm just gonna put the chord going here. I also know I have to go to the center of the circle. Center of the circle is going to be located down here. Okay? Now, what we also know is that these two radiuses, you can see them here above. I'm just got radii, thank you. they're here. So we have radius here, radius here. Okay. We also know that there's a height difference between here and here of how much? 1.5 is to 2.5. That is 1 meter. So I'm going to draw a line going directly down like so. So what I know is that this here is 1 meter. I'm going to call that x. I'm going to half my 3 meters to turn that into 1.5. I'm going to turn that into 1.5. And it's exactly the same trick we used earlier. So we have two different things we can say. Radius equals x plus 1. Would you agree with that?
Yeah.
You can see this big blue line here. That's your radius. Okay. So another thing, by Pythagoras' theorem, radius also equals x squared plus 1.5 squared. Now we're going to go straight for the radius this time. So to go straight for the radius, what we're going to say is that x equals r minus 1. So r squared is going to equal r minus 1 squared. 1.5 squared we already know is 2.25. We're going to multiply that out. R squared equals r squared minus 2r plus 1 plus our 2.25. R squareds cancel. 2r to the other side. 2r equals 3.25. Divide 3.25 by 2 and you get 1.625 meters. Same answer back to the book. Okay? Now, r equals 1.625 meters. Now, find the angle theta correct to one decimal place. Angle theta belongs to the triangle there, so we can just work predominantly on that triangle. 1.625. So we might just do this the Connor-Whelan method. Okay. So Connor-Whelan method would say that both triangles are congruent. Okay, because you have a common angle and then common sides as well. The hypotenuse is the same. They're congruent by RHS. I'll just get a bit technical here. One's a right angle, the other one's a right angle. One's a the hypotenuse are both radiuses, and the other side is about 1.5. Therefore, triangles are congruent by RHS. Now that we know this, what we're next going to do is I want to find this big angle here, don't I? You could do the cosine rule. You could do 3 squared and then my 1.625 on both sides, and I could do a cosine rule to find the angle x, which is, oh wait, I already used x, let's call it m. Yeah. M for Mark, right? Now, okay. Now, we could do it that way, or we could actually go about putting an A in here, okay, and just calling this, that's 1.625. So what Connor-Whelan would have asked me to do would be to use sine A equals 1.5 over 1.625. We're going to sine inverse that. So we're going to, first of all, go back on your regular mode. Make sure you're in degrees. Last thing you want to do come leaving cert time. Sine inverse 1.5 divided by 1.625. Then we get 67.38. Multiply that answer by 2. And you get 134.8. Okay? That was over 1.625. Angle M was equal to 2A. Therefore, as done by the calculator, M equals 134.8 degrees. Everybody happy with that? Okay, well, 134.8. Perfect. Now, calculate the length of the arc correct to one decimal place. The arc is this red line here. Okay, the outer perimeter. So what we say here is this. We're going to say that arc is equal to L equals theta over 360 by 2 pi r. And what that is going to equal is L equals, what's it, 134.8 divided by 360 multiplied by 2 times pi times a radius of 1.625. And we're going to get there. Going to just divide that by 360. I think Foley might beat me to it. And then multiply by 2, multiply by 1.625. What you get? 1.21. Anybody else get something different? Oh, they multiply by pi, yeah.
Yeah, 3.82.
Perfect. Okay, so L equals 3.82 meters. Okay, there's your L. Now, this is the good one, and I disagree with the back of the book on this one. Right? I want to see if I actually get the same answer second time around. Okay, so what I'm going to suggest is this. I can get rid of all this now for a minute. Now, here's what I'm suggesting we do for this. I am first of all, I'm going to find the. We'll just get rid of that for a second. So here's what I'm going to do. To get points on the board, I am going to find the area of the rectangle. So you can see here, I have to find the area of the full thing. Everybody agreed with that? Area of the full thing? Now, here's what's going to happen. I'm first of all going to find the area of the blue rectangle, going all the way up. Easy money, okay? So area of blue rectangle is just basically 1.5 multiplied by 3, 4.5 meters squared. Easy money right there, okay? Second one, I'm now going to find the area of the red, the red sector. Red sector, did I already find that? No, I didn't. So theta over 360 multiplied by pi r squared. So that's the area of the red sector, so to speak, okay? So what we're going to get is 134.8 divided by 360 multiplied by pi multiplied by 1.625 squared. Will somebody tell me what you got for that?
Not 3.8.
Sorry?
So we just did that.
No, we did length of the arc. We did 2 pi r instead of pi r squared. So what should we get for that? Any takers? Simon? One of the guys, Connor there, thought up the interpretation. My interpretation was covering it my interpretation was covering the full tunnel at the end. A second interpretation is to cover the outside of the tunnel, so you can travel through it. So what we're doing is we're taking the area of the face. What other people are thinking is, what about taking how much covering would you need to go around the outside? Okay, so we're going to do both of them anyway and see what the two results come out as. Okay, then we can compare it to the back of the book. Okay, so I'm just going to continue with the one I just did. So we got 3.106. Now, what happens here is I've double counted this green triangle twice. I counted it once in the blue rectangle, and I counted it a second time in the red arc. So minus 2 times your green triangle. Does that make sense?
No, it should be minus 1. Take it out twice. So you see that? Yeah, that means you're taking it out altogether. You have to take it out once.
Oh, take it out once.
Yeah. So
Okay.
you counted it twice.
Sorry.
Take it out once. And it's still there.
Okay. Yeah.
You know what I mean?
Yeah. Take it out once.
Yeah.
That's where I'm wrong. Now, take it out once, guys. Excuse me. Sorry, guys. You take it out once. My bad. Now, this one here, we said earlier we had base by height at our disposal. We know that the base is 3 meters. What did we figure out was the x value from earlier? Anybody remember the x value from earlier?
Oh, you know the radius. 1.5? No. It's something 1.62.
Oh, here. I have a quicker way, right? We'll just do a half AB sine sig. So we knew that's 134.8. 134.8 from 180, half it. Okay, and then we're going to divide this by 2. And what we get here is 22.6. Yeah. So this 22.6, we can now do is a half 3 meters, a half AB sine sig. And what do we get for sine? Sine 22.6. Anybody know what the green area is then? Green area? 1.129? No. Okay, let's try it.
Yeah, that's what I got.
I think you should get 0.936.
0.936.
Yeah, I agree with you guys. That's what I got last night. Or yesterday after you guys left. Now, add the two of them together. Take away 0.9. 0.9367, is it?
That's what I got.
Okay. Thank you.
Oh yeah, I don't know what you were doing.
What did you say? 0.9? 367. Okay, add them together. Blue plus red minus green. What you get? Blue plus red minus green.
6.66.
6.6?
67.
67 meters squared. As it turns out, that's the answer we're looking for in the back of the book. Round up to 7 meters squared.
Yeah, that would be